3-point charges lie along the y-axis at x equals 0 centimeters, 2 centimeters, and 10 centimeters. If the three charges are negative 6 microcoulombs, positive 4 microcoulombs, and 5 microcoulombs respectively, what is the net force on the middle charge? Be sure to include direction. Step 1, we're going to draw a picture. So it's along the y-axis. So we'll go ahead and draw the y-axis. And we had 0 centimeters, 2, and 10. So I'm going to make this bottom point the origin. So 0 centimeters, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, and then we'll label this. This is 5 centimeters and 10 centimeters. Okay. Now let's go ahead and label some more things. If the three charges are negative 6 microcoulombs, 4 and 5 microcoulombs respectively. So that means the first one is at 0. So there is a charge at the origin, and that is the first charge, which is negative 6 microcoulombs. I'm going to call this Q negative 6. Instead of just Q1, Q2, Q3, that can get a little confusing, just label it with the actual charge. So I've got Q negative 6, and then I've got the second one is at 2 centimeters, and it has a charge of a positive 4 microcoulombs. I'm going to call this Q4. And then the last charge is at 10 centimeters, and it has a charge of 5 microcoulombs. So we'll call it Q5. Now, the question asks us, what is the net force on the middle charge? Okay? So I'm going to make sure that I know I'm talking about the middle charge the whole time by putting a box around the middle charge. Okay? To remind myself, which charge am I trying to figure out? Okay? Because there's going to be a force on Q5, there's going to be force on Q4 from each other, there's going to be force on Q5 because of Q6, there's going to be force on Q4 because of 6. We've got a lot of things going on. I want to remember this is the one I'm focused on. Okay? So what we're going to do is we're going to find the force on 4 by 6, and then find the force on 4 by 5, and then we will combine those. So let's go ahead and find the force on charge 4, force on charge 4 by charge 6. Okay, we use our equation here, Coulomb's constant times the first charge, which we're saying is Q4, times the second charge, which is Q6, and it is the negative 1, over the distance between the two squared. Okay, now when we go to substitute in, we want to make sure that we have everything in the proper units. So the constant, we are always given in the proper units. It's 8.99 times 10 to the 9th. But then we have to check. This is 4 microcoulombs. So that is 4 times 10 to the negative 6 coulombs. And then 6 microcoulombs, so that is 6 times 10 to the negative 6 coulombs. And it is a negative 6, but we're going to leave the negative out right now because the negatives are telling us about the direction it's going to go. It's going to be attracted or repelled, but it doesn't tell us up, down, left, or right. So we're going to leave that till the end. Divided by the distance between them squared, well, the distance between these two is 2 centimeters. We need it to be in meters, so I need to convert that. And then that distance squared. Go ahead and type this in. We're going to get a force of 539 and 4/10 newtons. And now is where I'm going to look at the positives and the negatives and decide which direction this is going, because a force is a vector. I am looking at charge 4. Yeah, it's 539.4 newtons. The direction is where we look at. This is a positive. Oops, sorry, pointing the wrong one. This is a positive charge, and Q6 is a negative charge. So they are attracted to each other. So that means that Q4 is going to feel a force downward. And Q6 would feel a force upward, but we're worried about 4. So 4 is feeling a force downward. So over here, my direction is downward. Okay, then let's go ahead and look at the force on charge 4 by charge 5. So the force on charge 4 by charge 5. So Coulomb's constant again, 8.99 times 10 to the 9th times the first charge is going to be 4 again, so 4 microcoulombs. And the second charge is going to be charge 5 microcoulombs. And the distance between these two, well, this is at 2, this is at 10, so that is 8 centimeters, so 0.08 squared. And we solve this and we get that it's 28.09 newtons. Significantly smaller. It's because of this distance here, okay? Definitely makes a big impact. Now, we want to know the direction. Well, we look at these two. They're both positive this time. And when we have like charges, they repel each other. So that means that this one's going to feel a force up, and Q4 is going to feel a force down. Okay? So we've got another downward force here for the direction. And now we're ready to find the net force. So the net force on charge 4 is going to be 539.4 newtons downward plus 28.09 newtons downward. And now here's where we can put the negatives in if we want. They're the same directions, we can just add them, but they're both downward, so we could make them negative as well. So the net force on charge 4 is 567.49 newtons. If you want to put the negative in, you can to signify it's going down, or you can draw an arrow. But they are going the same direction, so it's going to add them together when we put them together.